Hey guys, welcome to my beginner Python tutorials. I'm going to try to keep the videos between 5 and 15 minutes because I want to get straight to the point, explain what it is exactly that you can expect from the topic that I'm going over, and then just go kind of experiment on your own. I don't want to get too crazy with like underlying mechanics of how it may or may not work, just because that could be a little too in depth for just kind of getting into programming initially. And I think if you can just kind of know what things do versus why things are, it'll be much more functional as you start. When you are a little bit more experienced with it, then you can start going into the whys, and then it'll really push your understanding of the language further. In this video, I'm going to go over lists, tuples, sets, and dictionaries. And there's quite a bit to go over, so I'm going to kind of go pretty quickly over them, and then you can kind of mess with them on your own. I'm going to try to explain some things about them specifically, and then how they kind of differ between each other. A dictionary being kind of the odd one out. That one's going to have some extra stuff towards the end. So the first thing is dealing with how big any of these are. There's a really quick and easy way to do this. You just simply use the lane function, and then which is built in, and then you will put the variable of whatever it is. So here I'm checking the list, tuple, set, and dictionary back to back to back, and it's going to tell me how big each of these are. As we can see, the first three are 10, and the dictionary is only showing 5. The only thing to note here is that even though there's 10 objects, you could say, in a dictionary is based off of key value pairs. The key is what is being counted, not the key plus the value. So a key value pair means that is one thing. So that's why 5 happens. The next big thing we need to go over is the order. So I'm pretty much going to stop talking about tuples because a tuple and a list are pretty much the same, except for the fact that a tuple cannot be changed. Once it's created, that's it. A list can be manipulated, removed from, added to, all that stuff like that, but they're both ordered. So if you want to ensure the integrity of something in a structure, you can use a tuple, and then it's always going to be there. If you need to use anything with it, you can make a new tuple out of the original, and then that could do something like that. Anyway, so going on to list and tuple, set, and dictionary, the set is the only one now that is unordered. The dictionary used to be, so if you're using an older version of Python, you might notice something different, but they're basically making it now so a dictionary is going to be or maintain the insertion order of whatever you put in. That's what's going to come out. The set is not going to do that, and of course the list and the tuple will maintain the order. So I'm going to print them out, and I'm going to do multiples, so you could see the set bouncing all over the place, and then you'll see the list and dictionary staying normal. Here, let me actually print this too, just so you could see it. All right, so I printed it, 5 or 6 times. The list, the tuple, and the dictionary are all same order every single time, and you could see the set bouncing around. That is a strength of a set, so don't think that that's a weakness. There's a reason why you want to use a set over a list, and it's more related to performance. So if order matters, you can use, if order matters and you don't need to change it, you could use a tuple. If order matters and you might need to change it, you can use a list. And if order does not matter and you're all about that performance, you could use a set. And dictionary and set function in the same way. A dictionary is also really fast. when you do certain checks on it. The next piece is indexing. Realistically, you can only index from a list in a tuple. I'm only showing the list here. What I'm doing here is attempting to index a set, and then I have what looks like indexing a dictionary, but I'll explain that. So if I want to know what the value is of some particular place in a list, each value or element in the list has a number associated with it starting from 0. That's the index. So the first element in a list is 0. So I can say, hey, give me the first element, and it'll give it to me. I can guess and say, give me the 5th element, and it'll give me that too. There's kind of a problem with just blindly asking for an element in a list, in that if you ask for an element, or if you ask for an index that isn't there, it's beyond the length of the list, it's going to give you an error. It'll crash your code. So here I'm actually just error handling it, so it'll catch it and say, hey, you can't do that. If you are trying to do something like that, then you definitely want to make sure you have something in place to prevent your code from crashing. The same thing on a set is going to happen. It's going to basically bark at you. It's going to crash your code because you can't index a set. It's unordered, so indexing a set would not make a whole lot of sense. And a dictionary, the index, it looks like I'm indexing, but what I'm actually doing is I'm asking for the value of a key. So I'm saying, hey, in example dictionary, give me the value of key 1. Not the first key, the key that is 1. So that should be A if I remember correctly. Yeah, it's going to be A. So I'm going to print these out, and you could see the command line kind of just confirming the things that I'm saying here. So we got this print here. It said, okay, printed 1. It tried to do the second one. It didn't work out very well because there's not 100 things in the list. For the set, can't index a set, got the exception. And for the dictionary, I asked for the value of key 1, and it gave me A. And I tried the same thing for 100, and it said, hey, the key's not in there. Now, remember, just as an example, let me put, so it's not like an index. I can ask for a value, and it's the same problem, right? It's not because I can't index it. It's because I can't, or because that's not there. Let me change this to 100, and then you'll see what I mean. So it printed out D, because a key in a dictionary could be a string or an integer. It doesn't matter. So that shows that. Moving on, there's a really cool operation you can run on all of these types, and that's checking if something is in there. This is useful for a lot of different reasons, and this will kind of explain why a set is good for performance and a list is good for ordered stuff or a tuple. Because the way a set works, it's unordered, but when you check to see if something's in there, you're pretty much jumping directly to that. There's some cool math involved with it, whereas a list needs to pretty much iterate over to find that item. And so the more you put in there, the longer it takes to check. So what I'm going to do first is print or check the time that it takes for a list and a set to see if this number 68 is in there. And I need to comment that. So when I run this check, you can see the numbers are kind of bouncing around. It's never going to be fully consistent, but the set seems to always be faster. Basically, because of that, you can assume, and I'm going to show you, that if they have the same amount but the set's faster, that's the one you want to go with, right? But if you need it to be ordered, then not so much. Let's see what happens when I make it bigger. So I'm just going to add a couple zeros to it. This is where the performance piece comes in. Oh, you know what? It's not doing a super great job at that. But as basically, if I make, I don't want to crash this because if I make this too big, it will. I think I could do that. Okay. The time in which it takes for a set will always kind of remain the same. And for a list, it's always going to get bigger. And this, I guess, wasn't super great in showing that. But essentially, a list, they're both going to get bigger as time goes on if you're adding data to them. And when you want to see if something's in it, you need to be conscious of that because it's going to cause like delays in your code. Or if you simply do the checks multiple times, if I do this check 4 times, and there's like, let's say a 50 millisecond difference, well, that's now 200 millisecond difference. And then it just keeps going from there. So as I check more, the time takes longer. If I'm doing one check, I don't need to convert it to a set to make it faster because the time it took to convert to the set probably took the time it would have taken for extra for the set, the performance gain of the set anyway. I hope that makes sense. I kind of said that a little wonky, but just know that sets are really good to use for performance if order doesn't matter. For the next 2 pieces, it's related specifically to dictionaries. Since these are like the odd ones out, there's a little extra things you need to know about them. Mainly for similar reasons to how when you are doing that thing that looks like indexing a dictionary, you're getting the value. You're using a key to get a value. When you check if something's in a dictionary, you're checking to see if a key is in there. And so when you kind of put those 2 things together, hey, if I can check if a key is in there and I can get a value from a key, can I go straight to a value? Yes, you can. So real quick, this check right here is just going to show that when I check to see if something's in there, 2 being a value or a key in the dictionary and A being a value, you'll just see that it'll only tell me that 2 is in there. Let me go up and show you again so you can confirm that. So A is a value. It doesn't see that at all. It only saw this. But because we know that I can use this syntax to say give me a value, and I can see if a key is in there, I can do some pretty fancy things. So the first one, right, is just normal. I'm iterating over the dictionary and I'm saying print me what you got. And that's going to be the key every time. So what I could do is say, hey, when I iterate over the dictionary, I now know the key. I know that's valid. Give me the value for that key in this format. And that makes it kind of dynamic while still guaranteeing that it's going to be in there for the most part, that is. This actually could be optimized a little bit better, and I could simply use a built-in Python function which will do that for me. Since that operation kind of already is like an important thing to do, what I'll do is I'll just say, hey, give me the dictionary values, and I do that by just appending dot values to the end of the dictionary. So now this item variable here is actually going to print out all the values, and I'm not going to get the keys at all. If I need to use both of them, that's a thing too, right? Maybe I want to do something with both. Then I could change the dot values to dot items, and it will give me both. When that happens, you need to make sure that you assign a variable to both, or else you'll have issues. In some cases, it'll smash them into a tuple. In some cases, it will not like what it sees and give you problems, like raise an exception or something. So I'm going to run this so you could see basically the difference between them. But it's pretty straightforward. Once you kind of get in there and start working with dictionaries, you'll kind of get a feel for it, and it'll be like really easy to manipulate. So we see it printed A, which is just on that first example print up here, and then 1, 2, 3, 100, 5 right here. And then here is where I'm printing out the values. And following, I'm printing out the values again. But like I said, these are two different ways of doing it. This is making like an explicit, hey, give me the value that this key has. Whereas this is simply doing it for me, iterating over the values basically, and assigning it to item without me having to explicitly ask for it. So there's some really complex stuff that you have to do to change any of these while you're iterating over them. So you can't change a tuple, so you don't have to worry about that. But a list, set, and a dictionary, if you iterate over it and you try to remove something or add something to it, it will not like that at all. It will cause many problems. So don't try to change them while you're iterating over them. There's probably other things that you can do to it that will cause the same problem. But if you really have to, what you can look into is essentially making a copy of them, iterating over the copy, and then changing the original. If you like the video, please like and subscribe. It'll let me know whether I should be making more of this stuff or not. Also, in the description, I'll have some links to things like my Twitch channel where I program live, as well as do network security stuff, pen testing, things like that. My notify.me, and any information related to like the operating system I use, text editor, and all that good stuff. Take it easy.